All right, these are the last two problems for math models. And it says use the matchstick figures for the following problems. Okay, so for number 4, if x is the height and y is the area, write a function that best fits the progression of the figure. Well, the height, well, this is a height of 1, this one has a height of 2, this one has a height of 3, height of 4. Okay, need the 4. So for 1, there is an area of 1. 2, there's an area of 3. 1, 2, 3, 4, 5, 6. And for 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's an area of 10. Okay? And it says write the function that best fits the progression of the figure. So it doesn't tell us to write which one, it says which one fits. So I'll start with differences. 3 minus 1 is 2, 6 minus 3 is 3, 10 minus 6 is 4, ooh, this looks quadratic already, 3 minus 2 is 1, and 4 minus 2 is also 1. So this one's quadratic. So, real fast, your a value, remember, second difference divided by 2, so a equals 1 divided by 2, that's 1/2. B equals your very first difference, which they don't give you. So we're going to have to back up. 2 minus 1 is 1. 1 minus 1 is 0. So our starting point is 0. And our very first difference is 1. So very first difference 1 minus 1/2 equals negative 1/2. So our a value is negative 1/2. Our b value is negative 1/2. And your c value, well, that's 0. And if you want to use 0.5 instead of 1/2, so it's fine. Who cares? So your equation is y equals 1/2 or 0.5x squared minus 1/2 or negative 0.5x. There's your equation. If the height is 7, what will the area be? So if the height is 7, well, all we got to do, the height is your x value, right? So we're going to take 7 and plug it in to my x's. So, negative 0.5 times 7 squared minus 0.5 times 7. No, it's not a negative 0.5, it's a positive 0.5. Oops, there we go. And we get 21. We'll get an area of 21. That's what we expect. Okay? If there were 15 sticks on the left side, what would the area be? Okay, this is the same stinking question. It just asks it a little bit differently. Remember the sticks on the left side? These are the sticks on the left side. Well, if there's 15 of those, well then the height is 15. Just asking it from a different angle is really all we're doing. See if you can see if you're processing it and you're willing to think about it. So 15 sticks, it means a height of 15, which means plug 15 in for x. So we're going to do 1/2 times 15 squared minus, is that a minus? Yep, minus 1/2 times 15. So stick in your calculator. 0.5 times 15 squared minus 0.5 times 15. And you get 105. 105. That would be the area if it was 15 units tall. Okay? Number 15 works very, very similarly. Similarly. Man, I can't speak. Go ahead and try number 15. Pause the video, try number 15, go for it. Alright? And hopefully you pause it and we're back, but let's go ahead and do it now. If x is the height and y is the number of sticks in the figure, so x is the height, so we're still measuring height, but y is the number of sticks. So let's start here. So we still got 1, 2, 3, 4, but they want us to count the sticks. So the first one has 1, 2, 3, 4 sticks. The second one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sticks. The next one has, let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It has 18 sticks. And the last one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 27, 28. There are 28 sticks in that pile. All right, and they tell us to write a function that best fits the progression. So we have to figure out what it is. Probably quadratic still because the other one was, but let's try it. 10 minus 4 is 6. 18 minus 10 is 8. 28 minus 10 is 10. And the second difference is 2. Yep, this is quadratic. So here we go. Our a value is 2. Our a value is the second difference divided by 2. So a equals 2 divided by 2, which is 1. B is our very first difference, which again we don't have. So that's a 2. 6 minus 2 is 4. 4 minus 4 is 0. So our C value is 0. And our very first difference is 3. Is 4, I mean. Very first difference is 4. That one right there. So here we go. It is 4 minus A, which is 1. So that's 3. And C is our start, so that's 0. So y equals 1x squared. I can just write x squared plus 3x plus 0. And for a height of 7, how many sticks are needed? So again, height is your x value. So take a 7 and plug it in for x. So 7 squared is 49, plus 7 times 3 is 21, so 49 plus 21 is 70. It will have 70 sticks. That's how many we'll need. To build from a height from 9 to 12, how many sticks will you be adding? Well, yeah, we need to do this twice. So we need to plug this in. So we need to find, I'll go ahead and put a little chart right here. We need to find both 9 and 12. And then figure out the different sticks. So if I plug in 9 in there, so 9 squared plus 3 times 9, that's 108 sticks. 12 squared plus 3 times 12, not 13, 12, we get 180. So how many more sticks would I need? So to go from here to there, I would need to add 72 sticks. Cool.